Thank you, everybody. And first, I want to acknowledge the Lake Ontario Prey Fish Working Group. This was it's basically a small group of folks most interested and work a lot on the prey fish in Lake Ontario, and we got together about 3 years ago to really provide some formalized way of actually critiquing what we're doing and understanding whether we're addressing the information needs of this broader group. And so we've been working together, meeting sporadically through the year, and a lot of the changes that we talk about, and especially a lot of what we've been learning, is a direct result of those individuals listed there. We actually got a little bit more diverse as well. We strong-armed Zy Biesinger from Fish and Wildlife to serve on our group as well. So today, I'm just going to first hit some of the highlights, and you really can't think about benthic fish without talking about that first bloater caught since 1983 in these trawls. As Steve mentioned, that Bob killed the one fish that was left in 1983, so it was really neat to see that. But interestingly, that was caught in the spring prey fish assessment, not the fall assessment. But that's important to keep in mind. We'll talk a little more about that later. The other thing is that whole lake trawl surveys have returned to Lake Ontario, the first since really 1972. It turns out our U.S. boats go right across that line in the middle of the lake quite easily, and we'll talk a lot about what we've learned by expanding to a whole lake perspective. And then finally, really just to sum up what we sort of think we've learned about benthic fishes is that, you know, from a round goby perspective, they really are gaining clout. Deep water sculpin are much more stout than what we had thought about, and wondering, are slimy sculpins getting squeezed out of the lake? So historically, the benthic prey fish survey, a bottom trawl survey, was operated in October and confined to about 6 transects on the southern shore of Lake Ontario, extended from about 8 meters out to about 150 meters. And this was anywhere from 55 to 60 trawls, and that formed the basis of what we knew or have known about benthic fishes along a time series in Lake Ontario. And what Bob and Joe Elrod and the folks designed that around was that there were a lot of slimy sculpin. And so that was a great place to assess changes and trends in slimy sculpin. But as the ecosystems change, you've heard folks mention that, and as our information management needs change, we really realized that we weren't necessarily getting what we need. For example, the FCO talks about diversity. Well, you might imagine just trawling along one sort of steep-sided shoreline of the lake makes it a little bit difficult to say this is the diversity of benthic prey fish in the lake. I would say it, I wouldn't stop from saying it, but wasn't as really sure about it. You know, goby are sort of a hot topic now in all the lakes. How sure were we about our assessments of those goby? Deep water sculpin. This is a native species that has been coming back basically on its own in Lake Ontario. But how sure of that were we? Were we actually getting at the real status of deep water sculpin? And then finally, measuring restoration. Steve had mentioned the bloater efforts, as well as Mike Connerton had been talking about the Cisco efforts. So these were our reasons to change, or at least the highlights of them. But one thing we wanted to do is recognize the history of people making changes to cruises, you know, in the Great Lakes, and some of the mistakes of the past where they missed some important things. And so the first we wanted was that critique. We wanted to get input both broadly about our lake, which is why we formed the Prey Fish Working Group, but also from other lakes. So we're talking often to our USGS and OMNRF colleagues and our Fish and Wildlife Service colleagues about the changes we're making, what they think of them, what we might be missing. We wanted the survey, anything we did, to be compatible. So in thinking about these time series, which are some of our best data for understanding sort of how human impacts have changed the Great Lakes, we needed, if we're going to change the survey design, we need alternative methods, more flexible analytical methods, where we move basically from a stratified random design for calculating abundance and things like that to a more flexible design that uses nonlinear models and basically takes more advantage of the information we have. we wanted, and I mentioned before, we wanted to think lake-wide. Any and everything was lake-wide. How do we understand Lake Ontario without putting it in the context of Lake Michigan, Lake Superior, any of the other big oligotrophic lakes? So to do that first, we have to understand how our trawls are working in terms of the area they're sweeping. And so we've been relying on a lot of different advanced tech to help us get these estimates. What's really kind of interesting, and I mentioned to Andrew, we're using every manner of camera and video things that we can do, and we're coming up with the same answers that Bob and crew figured out, 20 years ago when they used a fly reel with the drag crank down to measure how wide the trawl spread, and come up and I'm like, hey, look, that's pretty reassuring that we're now getting the same numbers that they figured out, with many thousands of more dollars spent. But we wanted to sample across drivers and gradients. Tom Stewart would often talk up here about these gradients that exist in Lake Ontario. The classic one is sort of the cold North Shore and the warm South Shore, and how we weren't adequately talking about the story that included those gradients and what those might do to drive the fish community changes. And then finally, we wanted to share data, not just within ourselves, but we wanted to put these data out that we're collecting. Others can look at them. If you crunch them the same way we did and we come up with the same interpretations, that lends a little bit more evidence that we know what we're doing. And so those are sort of our considerations. And again, I mentioned our historic sites here, and then our 2015 sites are marked here. So the historic sites are still in green, and then you can see color-coded. The way we did this was just, we got help. So really this whole lake survey was born out of a charge from the Lake Ontario Committee, I want to say in 2013 or 2012, to create holistic whole lake 3-boat surveys. And so the Benthic Prayfish is the first to do this, and we did it by the group up in Cape Vincent on the RV Seth Green, doing a bunch of the Eastern Lake. Jeremy Holden and the crew out of Picton coming around the edge and traveling across the North Shore and doing a lot of sampling. And then, as I mentioned, our boat heading down to the west and hanging out with folks in Hamilton and seeing baseball games in Toronto. We're now getting around the lake, and we're also actually getting into that middle area of the lake as well. So what this basically did was it paired our sampling effort more closely with the available distribution in the lake. Here, the distribution of depths in the lake in a 20-meter bin is the black series of bars, and how we were surveying maybe in 2000, as an example, is on the gray. So we were underrepresented relative to the lake shallow, we were quite unrepresented deep, and then maybe in the middle we were oversampling. Now again, this was designed around slimy sculpins. That's the area slimy sculpins are most variable, so it makes sense. Whereas in 2015, now our sampling distribution there in the light blue is much more closely matched to the lake. Interestingly, we're still missing a little bit of time out there, or trawls out in the 160 to 190 meter range, and I'll mention why that's important. It's probably the one place where we actually need the most information now. We've learned we need more trawls out there. And the reason for that is because of these deep water sculpin and what we're learning now. So these next series of graphs are going to show you fishing depth along the x-axis and the density. Remember I mentioned that, let's talk numbers per meter squared or numbers per hectare. We know they're underestimates because our trawl doesn't catch every fish. We're likely missing some fish, but we've got points of reference that we're improving upon. And so if we look at our historic sites, we see, yeah, those 55 sites showed there are significant deep waters. There's more sort of in that 80 to 90 meter range. There's a bunch of juveniles in that range. And the nonlinear model will fit and give us, we can scale that up to a whole lake estimate. Yet if we use all the survey data from 135 sites, we realize we're kind of missing some information by sampling where we were. Deep water sculpin are much, much more abundant throughout the lake in places where we were not sampling. Colleague Dan Yule put it once, if you go sample somewhere else, you're likely to learn something new. And I thought that was both annoying but poetic, because we just learned so much more about deep water sculpin in one single seasons of a survey than we had ever known before. I failed to mention, deep water sculpin are species of concerns in both New York and Ontario, and so they're being reevaluated. People are asking us for those data, and we're like, here's the data, but we're not sure they're the best data. Now we're a lot more confident in knowing where this population is at. In fact, here's just a heat map where the colors represent the density of where these fish are. And we've known before that that area right in the middle of the Mississauga Basin was a hot spot. We just didn't quite know how hot it was. But also note down to the far left of the graph, that's the Niagara Basin. There were lots of deep water sculpin down there. There's also deep water sculpin in the Eastern Basin. So these things are spread out, and we're still, working to improve upon this map, hopefully get a couple more points out there in the middle to really know what we're talking about. We didn't figure this out, but we finally figured out that the blue and red phase mentioned there, a blue phase is a very gravid female. Not all females are blue, but all the blue ones were very gravid females. There's another picture from the underside of the different coloration of that, of these fish that are out there. So this resulted in quite a large increase in our density index for deep water sculpin. Now we have a couple different, if you look at the report, a couple different iterations of this that talk about more restricted, more consistent sampling indices, like just from 150 in. They match pretty well with this. So then how about with round goby? Well, we didn't learn that much more, but we have great precision and better understanding and confidence that those sampling methods are indeed capturing gobies where they're at. For that, all indices are up. The fall density indice is there in the black line, and the spring density, we use those same data that Maureen talked about yesterday to index goby, because we're not really sure which the best indices are, and gobies have this seasonal movement up and down the bank that make it difficult to assess. Point being, there are a lot of gobies out there, so for your lake trout, there's especially a lot of small gobies. It was a great year for, the past 2 years were great for goby in terms of recruitment. We learned slimy sculpins, the ones that were maybe getting squeezed out, we weren't missing them. Their densities were about the same. We just got more data, but their numbers are down. In fact, this in the recent time period is the lowest density of slimy sculpin we ever caught. And we started thinking about why that might be. If we look at the number of juveniles, and here we're just calling a juvenile as anything less than 50 millimeters, about 2 inches, you see the proportion of those in our catch has really just plummeted on somewhere around 2005. This is just correlational, it's not a causation, but that happens to time out really well with when round goby moved into the system and really expanded. If we think about that, sort of how that's happening, here I look at the fall depth distribution where the fishing depth again on the x-axis. Now I've just scaled the y-axis, so it's basically scaled to their maximum value. Gobies, slimies, and deep waters, you see slimies are kind of caught in the middle, but again I mentioned those gobies are going to continually move offshore during the winter until they come to rest somewhere out here. This is the distribution from the spring of 2015. So you can see sort of they're going to overlap with a slimy sculpin, or goby will cross over that entire distribution of slimy sculpin. And because we sampled in some new places, we actually found some of those other native benthic fish, some of that diversity we talked about that's kind of hard to find in Lake Ontario. We looked at that relative to round goby. It's a pretty strong negative relationship. Where you find goby, you don't find those native benthic fishes, and where you do find them, you find very few goby. So just something for the committee thinking about, and diversity and whatnot. And then finally, this is a thing we just pulled together to add some context. How do benthic fishes, how are they relevant to the pelagic fishes? And we came up with it was originally we adopted this from stoichiometry, just looking at the ratio. It was originally the alewife goby smelt indice, that they're about 38 alewife to 8 goby to 1 smelt. We put everything in smelt equivalents, and so if we actually add deep waters to about 0.5 deep water sculpin. So that just gives some context. It's still an alewife dominated system, but you know, it shows where round goby are fitting numbers wise. And then I'll finish it up and take questions with this. This was a picture of the catch down in Hamilton Harbor where I explained to our new technician when she was worried about identifying the fish. I'm like, don't worry about it. The silver ones are alewife, the brown ones are goby, and the rocks are mussels. Just, you're cool. And we get down there, and this is the first tow, and we caught some of everything. So turns out Yule is probably right about that, too. When we went to new places, we caught new things, including a whole lot of lake and round whitefish down in the western zone, a lot of juveniles. So something to be thinking about for those species and their distribution around the lake. With that, I'll take some questions.